All right, this is warm up number 10. Let's go ahead and take a look at number 1. It says triangle XYZ will be rotated clockwise using the rule. Well, this rule that they have in here shows a reflection over X and a reflection over Y. So what happens whenever there's a reflection, I like to do it one at a time. So I'm going to do the reflection over the x-axis first. What that means is that here is the x-axis. And so for something to reflect over the x-axis means that if it's exactly 2 away right here, then it's going to be exactly 2 away right here. So I'm going to put my first coordinate point, and this was corner Y. So I'm going to call this Y prime. And then this is 1, 2, 3, 4, 5, 6 spaces. So 1, 2, 3, 4, 5, 6 spaces. And I'm going to put my dot here. This one is going to be X. So now we can draw that back side of that, or X prime, excuse me. And then we can see here that from X it goes 1, 2, 3, 4, 5, 6, 7 spaces for Z. So 1, 2, 3, 4, 5, 6, 7. So here's Z prime. So now we have drawn over the X reflection. We should go ahead and do the Y reflection. So now we're going to take exactly what we have, except for now we're going to reflect it over the y-axis, which means here's the y-axis, and a reflection is if this is exactly 2 spaces away, then you move it exactly 2 spaces away right here. So this one is technically Z prime prime, and then we know that it is 7 spaces, so 1, 2, 3, 4, 5, 6, 7. So this one is going to be Y prime prime. And then, of course, the last part up 1, 2, 3, 4, 5, 6 spaces right here. This will be X prime prime. So we give it double prime. And there's our final image. So now we've done it twice because we had to do it once for this minus sign and once for that minus sign. Those minus signs, algebraically, they mean that that is a reflection. So here, when they say find the location of X, they probably did it all in one swift move and got to this location up here, which this location is an actual coordinate point of X is 9 and Y is also, Y is 8. When I come across here and I look, Y is 8. Okay, so now we know 9, 8 goes right there. Describe the degrees of rotation. Well, if you go once, if you flip it once to a square, that's 90 degrees. But if you flip a square twice, then that gets you up to 180 degrees. 90 and 90 gets you to 180. Let's look at number 2. It says Liam translated a quadrilateral 7 units left and 3 units up. If A is located at -1, -1, find the location of A prime. Well, I have to draw a picture to help me out because now if I'm here and I say I like to label my X and Y axis, this is -1, -1 would be right here. Well, I have to move this 7 units left and 3 units up. So if I were going to move it 7 units left, I would go 1, 2, 3, 4, 5, 6, 7 units left. And then that would get me right here, technically down right there. But I'm not done, so I have to go 3 units up, which is up 1, 2, 3 units. So that would get me this location right here, because then this went over 7 and up 3. This would get me to -8, comma 2. That is the new location, is -8, comma 2. Now it says represent the translation with an algebraic rule. Well, what did we do to the x value? On the x value, to move it 7 units left, well, we went more negative, so we subtracted 7. And what did we do to our y value? Our y value, we moved it up 3, so that would be adding 3 to it. All right. Now, the final one that they want us to look at today is to write an algebraic rule to represent the reflection represented on the table and identify the line. Well, what you have to do first is you have to identify what changed. So from A to A prime, I see that the 5 is the same, but the 3 is now negative. The B, or it's positive. Sorry, it started off negative and now it's positive. And now it was negative, positive, negative, positive. So what that tells me is that the only thing that changed was in the coordinate points, there was the sign of the y changed, and that is called a vertical reflection. The reason why it's vertical is because the y-axis goes up and down like this, and the y-axis is actually vertical. All right.